All right, in this lecture, we're going to be talking about future annuities. Okay, an annuity is basically like an allotment. Like if you're putting away money of equal value at equal intervals of time into an account, that's basically an annuity. Okay, and the future value of an annuity is the sum of all the payments that you put in plus the interest that's accrued on the payments. There is a formula, of course, that goes with future value of an annuity, and it's the future value, which remember we call A, equals the payment that you put in, 1 plus I raised to the n power minus 1, all over I. Okay? Now, what I want to tell you is, remember, future value we called A. I was R over N. So I just want to show you what your book has, because your book uses SV and I use R over N and A. So it's the same thing, depending on, what you're going by. It's exactly the same thing. I just want you to be comfortable with both. So one thing that you want to learn is to find your I, okay? Because remember, not everyone has those fancy TI calculators. So if you can just kind of break, things apart, find specific values, it'll be easier to compute it in your calculator. Okay, so let's look at this problem. I want to find I and N for the following annuity. You're making monthly deposits of $270, and they're made for 4 years into an annuity that pays 8.5% compounded monthly, okay? So, you know that your compounded monthly, your rate is 8.5%, but remember you can't present it that way. You have to change it into a decimal. So I'm going to move it over twice, so it's going to be 0.085 for my R. I would equal 0.085 divided by 12, since it's being compounded monthly. So I is 0.0071 if rounded to 4 decimal places. 0.0071. Easy peasy. Now let's find N. Now, if you looked at the formula, go back and look at the formula that you just wrote down for future value. You had 1 plus I raised to the n power. But what you need to know, you guys, is N equals the number of payments made. Okay? It's the number of payments made. So think about it. You're making monthly payments. So that's 12 times in a year. For how many years? For 4 years. So wouldn't that be 48 payments? And that's your answer. Okay, so here's the new problem. I want you to try this one by yourself. So let's read it together and then go ahead and pause the lecture, try it yourself, and then come back and see if you got the right answer. Find I and N for the following annuity, so same directions. You have a semi-annual deposit of $1,800, and they're made for 15 years into an annuity that pays 8.3% compounded semi-annually. So pause it and try this yourself. All right, this is what you should have got. You should have changed your percentage into a decimal, which means you moved it over twice, so 0.083 divided by 2, because compounded semi-annually means you're making 2 payments a year, and also interest is occurring 2 times a year. So 0.083 divided by 2 is 0.0415. Then to find N, which is the number of payments, like I said, you're making 2 payments a year because you're making semi-annual deposits for 15 years, so that's 30 payments total. Okay, so now that we can figure out I and N, let's go ahead and have some fun with this future value formula. So you're going to use the future value formula to find the indicated value. I'm telling you that N is 27, so I'm telling you you're going to make 27 payments. Your I is 0.03, remember I is R over N. Your payment is $90, and your future value, that's what we're looking for. Now, hold on, I want to clear something up because I kind of caught how something can be confusing. N equals the number of payments, okay? when I say I is R over N, it's I is your rate over the number of times something's compounded. So remember, if that is monthly, then that is 12. If it's daily, then it's 360, 365, depending on what they want you to use. So just be really careful. There's kind of like an N, and they're using it two different ways. N could be the number of times you make payments throughout the course of the annuity, and then of course this N that I'm talking about is the number of times that something's compounded. So just be really careful with that. So all you have to do here is fill in all of the information. You're just filling in the formula. It's kind of like a plug and chug. You're having 90, open parentheses, 1 plus I, which is 0.03, raised to 27 minus 1, all over 0.03. Now you want to be really careful how you put this in your calculator, you guys, okay? Maybe you just want to do the 1 plus 0.03 to the 27th power first, then subtract 1, then divide by 0.03, then multiply by 90, and you'll get the correct answer. If you round that to the nearest cent, you get 3,663.87 cents. So that would be your final answer, and I took it piece by piece. If you're putting it all in your calculator at the same time and you're not breaking it up piece by piece, that's fine. You're going to type in 90, parentheses open. You want to open up parentheses again. Type all of this in, close parentheses, divided by, open parentheses, type this in, close parentheses, and then close parentheses again. So when you're putting it all in one time, you have to be really careful with the amount of parentheses that you put. If you open a set of parentheses, you have to close your set of parentheses, and you need to make sure all of your parentheses make sense, which is why I would suggest just to break it up piece by piece. Okay, now try this problem. Okay, here's the formula. I'm going to fill in what we know. So we have 4968. We are looking for payment, so I'm going to leave that PMT. 1 plus 0.09 to the 9th power. My 9's come out so bad. Minus 1 all over 0.09. Okay, so what I would try to do first is try to simplify this, okay? Go ahead and put in your calculator. Open up parentheses, 1 plus 0.09, close parentheses, raise to the 9th power, then subtract 1, then divide by 0.09. Now I have a TI-84 calculator. So what I'm typing in is parentheses open, 1 plus 0.09, close parentheses. I'm using the caret to raise it to the 9th power. Then I hit enter, and I get 2.171893279. Then I'm going to hit minus 1. If you just hit minus 1, answer will pop up. Answer minus 1. So then I have 1.17 and some change. Now I'm going to divide by 0.09. So it says answer again, divide by 0.09. And what that does, it just takes your answer that you have previously and uses that. I hit enter, I get 13.021. So I have 13.021 times your payment, because remember, this is being multiplied right there, equals 4,968. So I'm going to do some basic algebra to get payment by itself. They're multiplying, so I'm going to divide by 13.021. And I get my payment is $381.54, if I round correctly. And that's your answer. All right, here's the new problem, and here, same directions, but we're going to solve for n this time. Okay, so I'm going to fill in what I know. 2,000 equals 400, open parentheses, 1 plus 0.02. We don't know what n is, so I'm just going to leave that in, minus 1, all over 0.02. Okay, you guys, so we've actually talked about this in a previous lecture and in the last module, that we need to solve for n, and n is an exponent. Okay, so we need to bring that exponent down to become a coefficient. But first, you want to get the exponential expression by itself. Now, this right here, you guys, let me get a different color. This is the exponential expression because that is the only thing that's being raised to the n power, which means we can get rid of everything else. And how I'm going to do that is this is 400 times all of that, so I'm going to divide both sides by 400. That's gone. So now I have 5 equals, and then this is gone, so I just have this part that's in parentheses left. They're dividing by 0.02. So then I'm going to multiply by 0.02 on both sides. Okay, so when I multiply by 0.02, that canceled this here. So all I have left is the numerator, and 0.02 times 5 is 0.1. They're subtracting 1, so I'm going to add 1 to both sides. Okay, so if you add 1 to both sides, this cancels, okay? 1 plus 0.1 is 1.1, which is where I got that, and all I have left is that. So that's the exponential expression by itself. I isolated the exponential expression. The next step is I have to take the natural log of both sides. So I'm going to take the natural log of 1.1, and I'm going to take the natural log of 1 plus 0.02, and that's raised to the n power. Now, why do I do that? Because if I take the natural log, I can take that exponent and bring it down to become a coefficient. So I have now a natural log of 1.1 equals n times the natural log of 1.02. I just went ahead and added it because 1 plus 0.02 is 1.02. So now I have n times this. So it's no longer an exponent, it's a coefficient that I can actually solve for. And how do I solve for it? Well, if they're multiplying by the natural log of 1.02, I'm going to divide by the natural log of 1.02 on both sides. That's gone, so n equals this. This is the exact answer. But go ahead and type that in your calculator and see what you get. And I got this to be about 4.813, and then you just round it to whatever your homework wants you to round it to. Okay? Okay, I want to try to squeeze in an application problem. A lot of y'all see word problems and you freeze up and you're like, I can't handle it. But I promise you that every word problem that is in your homework is something basic that we've done before. You just have to pull out what you know. For example, this one says, recently Company A offered an annuity that pays 4.5%, so you know that that's your R. You know that your R is 4.5%, and we're going to have to write it as 0.045. Okay. Compounded monthly. So you know the number of times compounded is, is 12. So can't you find I now? Because you know that your rate and the number of times compounded. So you know that R is 0.045 divided by 12, which is what we did earlier in this lecture. So I is going to be 0.00375. Okay, let's keep reading. If 118 is deposited every month, so isn't that my PMT? How much is in the account after 5 years? How much is in the account after 5 years? That's your T. But aren't you looking for future value? Right? So isn't N the number of payments? If you're in the account for 5 years and you're making a deposit every month, then that means 12 payments for 5 years. You're going to make 60 payments. We've already done this. All right. So I just want to give us a little bit more room so we can go ahead and work out this problem. Everything that you see in red that doesn't have purple underlining is what we pulled from the problem. Since they gave us R and N, we found I. Since they told us that we've deposited monthly and for how many years, we can find N, the number of payments. And they told us that the payment was 818. So now I'm going to write down my formula. Okay, so I just filled in everything that we knew. I just plugged in all of the information, and then when I put this in my calculator, I get that the future value of this annuity is $54,925.06. Okay? So that was the first question. How much money is going to be in the account after 5 years? That's how much money is going to be in the account after 5 years. Then it asked the second question. It said, how much of this is interest earned? Now remember, interest is all of the money that's tacked on to what you've already made. So you're depositing $818, right? How many times did you deposit $818? You deposited $818 60 times. So let's do that math. You did $818 60 times. So the amount of money that you put into the account is $49,080. 49,000, that's a comma, $80. That's how much money you put into the account. But that's not how much money is in the account, because the rest of that money is interest. So to get interest, I'm going to take how much money is actually in the account, and I'm going to subtract how much money you put in the account, and that will give you your interest. So that is $5,845 approximately. $5,845 of interest. So I just want you to know, I know some of you are going to be like, well, Mrs. Seeley does the easy questions. She does the ones that are not word problems. Well, it's because the word problems, you guys, are exactly the same. You just have to learn how to think. You have to learn how to pull out the pertinent information. Everything else, we've done all of this. We've done all of this in the simple computational problems in the beginning. So you just have to think, pull out the pertinent information, make sure you're answering the questions being asked. Okay, and if y'all have any questions,